So here the first question is how to define, okay, how to define the length. How to define the length of a curve. The second is what's the formula? What's the formula of the length? Okay, what's the formula of the length? So here we have this question. Okay, so now we see page 352. 352 here. So we have this question. So here arc length problem. Okay. So arc length problem. Suppose that y equal to fx. This function is a smooth curve. Okay, is a smooth curve. It's a smooth curve on the interval. On the interval AB, okay, on the interval AB. And now we need to define, okay? We need to define and find. We need to define and find a formula. Find a formula for the arc length, okay? For the arc length L of the curve y equal to fx. Y equal to fx over the interval. Over the interval AB, okay? Over the interval AB here. So this is the question, okay? This is the question. So here, suppose that y equal to fx. Here, this function or this curve is a smooth curve. So here means, here we have a, what means smooth, okay? What mean of smooth? So smooth here, smooth, okay? So here, smooth curve. Here means the function fx is continuous, and the derivative f prime, okay, is also continuous, okay, is also continuous. So this means the smooth, okay. Smooth means f and f prime are continuous, okay. This is the meaning of smooth. So here we give a smooth function on the interval AB. Now we need to define, okay? We need to define and find a formula, okay? A formula for the arc length L of the curve y equal to fx over the interval AB, okay? Over the interval AB. So here. So we have this question, okay? This question. So I think that it's the same, okay? So here, for example, here is y equal to fx, okay? Here is y equal to fx. Here is from A. Here is y, here is x, here is the origin. So here, the left is A, okay? The right is B, So now we need to find the arc length of y equal to fx over the interval AB, okay? So actually it's the same, okay? We have three steps. The step one, so the step one is the same, okay? So partition. And then the second is summation, the right is taking the limit, okay? Taking the limit. So here we use these three steps to find the formula of the arc length, okay? So the first step, So the step 1 is a partition, okay? Partition, so the same, okay? So divide, okay? So divide it to close the interval AB into n subintervals, okay? N subintervals. So here, for example, here is x1, here is x2, okay, here is x2, so go on, here is xn minus 1, okay, here is xn minus 1. So here the first step, partition, okay, so here we can obtain the x0 is A, okay, and x1, x2, go on, here is xn minus 1, less than xn is B, okay, B. So the first step, and we can obtain what? We have obtained the subinterval. So the subinterval actually is x0, x1, and x1, x2, okay? xn minus 1, xn, okay? xn. So now the same, okay, what's the y's of the first subinterval? Is delta x1 actually is x1 minus x0, delta x2 actually is x2 minus x1, okay, so go on, here is delta xn equal to xn minus xn minus 1, okay? So this is the first step, okay? So the second step here is the summation, okay? Summation. So here is x1, okay? x1, so here we have the first point. The left point, okay? The left point here we denote it by P0, okay? P0 actually is A, FA, okay? So P0 actually is A, O, X0, FX0, okay? So it's P0, and P1, we denote for P1 by X1, Fx1, okay? So here P1 we denote by X1, Fx1, okay? And the P2 this point, okay, we denote by P2. P2 we denote by X2, Fx2, okay? Fx2. So go on here, we denote by Pn minus 1. Pn minus 1 we denote by what? Xn minus 1, Fxn minus 1, okay? And Pn we denote by Xn, Fxn, okay, Fxn. So here we got n plus 1 points. P0, P1, P2, Pn minus 1, Pn, okay? So here now we can see what? So we can see the length, okay? The arc length we denoted by L, okay? L. So the L actually equal to what? Equal to the length of part P0, P1, okay? So here we use this notation like a hat, okay? Like a hat. We use this notation like a hat. P0, P1 hat, okay? P0, P1 hat, we denote the arc length on this is some interval, okay? And so L actually equal to the height P0, P1 height plus what? Plus P1, P2 height, yeah? Yes. Plus Pn minus 1 Pn height, yeah? Yeah?
Yes.
So here, So now we can see the first, okay? So when this subinterval is small, okay? When this subinterval is small, actually we can use what? We can use what to approximate the P0, P1 hat. So here we use the non-segment, okay? We use the non-segment P0, P1, okay? P0, P1 to approximate the P0, P1 hat. And we use P1, the non-segment P0, P1, okay? We use the non-segment P1, P2. We use the non-segment P1, P2 to approximate P1, P2 hat. So it's like this, we use Pn minus 1, Pn, okay? We use the non-segment Pn minus 1, Pn to approximate the Pn minus 1, Pn hat, okay? So here means what? The first one, okay? The first one approximately equal to what? P0, P1, we use the non-segment P0, P1 to approximate P0, P1 hat. And we use the non-segment P1, P2 to approximate P1, P2 hat.
Yes.
So go on. So the last one here we use Pn minus 1 Pn. We use the non-segment of Pn minus 1 Pn to approximate Pn minus 1 Pn hat. Okay? So here we have a question. So P0, P1, what's the names of P0, P1? P0 is x0, fx0. P1 is x1, fx1. So P0, P1 equal to what? So P0, P1 actually equal to the square root x0 or x1 minus x0 square plus fx1 minus fx0 square. Yeah? Take the square root. Yeah? So here actually is x1 minus x0 square plus fx1 minus fx1 x0 square root. Okay, square root. So P0, P1 equal to here. So now we can see fx1 minus fx0 is what? fx1 minus fx0 is delta x1. Yeah? So here the first part actually is the square root delta x1 square, yeah? So the second fx1 minus fx0, fx1 minus fx0, actually we can here, in this subinterval, we can use the mean value theorem, okay? Because this function is continuous on the closed interval AB. So fx is also continuous on the small subinterval. Because fx is the f prime, okay, f prime is continuous on the closed interval, so means fx is definable on the bigger interval, okay. So of course fx is definable on the subinterval, okay. So we can use what? We can use the mean value theorem. The mean value theorem means what? fx1 minus fx0 divided by x1 minus x0. There we have a point. We have a point we denoted by x1 star. We have a point x1 star such that the derivative at fx1 star equal to fx1 minus fx0 divided by x1 minus x0. Yeah? This is the mean value theorem, okay?
Yes.
You remember it?
Yes.
So here, this part, x1 minus x0 actually is delta x1, okay? So here actually is fx1 minus fx0 by delta x1. So from here we have what? So from here we have fx1 minus fx0 actually equal to f prime x1 star times delta x1. Yeah? Here we times delta x1 on both sides. So here we can obtain fx1 minus fx0 equal to f prime x1 star times delta x1. Here x1 star, okay? Here x1 star in the first subinterval, okay? So here we substituting this formula to here. So this actually plus fx1 star delta x1 here the whole square, okay, the whole square. So now we have here delta x1 star, here delta x1 square here actually we can rewrite it by what? Either by the square root delta x1 star plus here a number times another number, the whole square, okay? So here equal to what? fx1 star square times delta x1 square, okay? So here delta x1 square, here delta x1 square, so take it out and square root. So actually here is the square root 1 plus fx1 star square. So times delta x1, okay, times delta x1. So here is p0, p1, okay. Here is p0, p1. So now p1, p2. So what's p1, p2? P1, P2, the line segment, okay, this line segment, the length of P1, P2 equal to what? Equal to the square root 1 plus fx2 star square times delta x2, yeah? Yeah. The same formula, yeah? Change here, x1 to x2 star. X2 star is belong to the second subinterval, okay? And here change delta x1 to delta x2, okay? Yes. So now go on. So here we have Pn minus 1 Pn equal to what? The square root 1 plus f prime xn star square times delta xn, okay? So here now we have what? So from here we have this number, okay? So we have L sub approximately equally to what? Equal to the square root 1 plus fx1 star f prime, okay? So I'm sorry, here actually is f prime, okay? Because here is prime. So here is also prime, okay? So here f prime x1 star square times delta x1 plus the square root 1 plus f prime x2 star square times delta x2, okay? So plus here is the square root 1 plus f prime xn star square delta xn, okay? Delta xn. So here we can write it in a summation. So this is equal to what? The summation of the square root 1 plus f prime xk star square times delta xk, okay? Yk runs from 1 to n, okay? So this is the step 2, okay? Step 2 summation. So what's the step 3? So the step 3, okay? Step 3 is taking the limit, yeah? Taking the limit. So taking the limit, okay? So L actually equal to what? L actually equal to limit delta max delta xk approaches 0, delta xk approaches 0. The summation of the square root 1 plus f prime xk star square, okay, times delta xk, okay, yk runs from 1 to n. So here actually is what? Is the definite integral, So here, the definite integral of the square root 1 plus f prime x square, f prime here square, okay, here square dx from what? From a to b, yeah? From a to b, okay? So this is the definition, and this is the definition of the arguments. And this is also the formula of the arguments, okay? So remember it, okay? So now let's see page 300. Now let's see 315, okay? 353. 353 here. 7.4.2, okay, 7.4.2, if y equal to fx is a smooth curve on the interval AB, then the arguments L of this curve over the subinterval AB is defined as L equal to the definite integral of the square root 1 plus f prime square dx. From A to B, okay, from A to B. So here, so this is the y equal to fx, okay. So y equal to fx from what? From A to B, okay, from A to B, okay. So here, so the next equal to the definite integral of 1 plus f prime x square dx from A to B, okay? So now, if the curve is given by x equal to f1, okay? So here the first x, y is a function of x, okay? X is from A to B, okay? Yeah. So if the curve is given by if the curve is given by x equal to gy, if the curve is given by x equal to gy, y belong to CD, So here, for this curve, what is the length? The length is the same, okay? L equal to the definite integral of the square root 1 plus g prime y, the whole square. And dy, y from C to D, okay? Y from C to D. Okay, so this is the formula. If the function is given by y equal to fx, so the formula is this formula, okay? If the function is given by x equal to gy, the formula is this formula, okay? So now I have a break, 20 minutes. So attendance, okay, here. Just sample yourself, okay?